Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I'm continuing my O-level past papers session, and I was doing IGCSE Chemistry 0620. I've selected October, November 2024, and I'm done with paper 61. This time I've selected paper 62. It's paper 6 alternative to practical. 1 hour is the time. You have to answer all the questions. You can use calculator in this paper. The total mark for this paper is 40. Important point, notes for use in qualitative analysis are provided in the question paper. This is the notes for use in qualitative analysis. It includes tests for anions, tests for cations, tests for gases, and the frame test for metal ions. So let's start the paper. Here is question number 1. A teacher uses the apparatus shown in figure 1.1 to pass an electric current through molten mercury 2 bromide at a temperature of 300 degrees centigrade. You see, it's a figure 1.1. There are mercury 2 bromide, electrodes, power supply, ice, and apparatus labeled A. During the process shown in figure 1.1, the molten mercury 2 bromide breaks down and forms bromine and mercury. Table 1.1 shows some information about mercury 2 bromide, bromine, and mercury. So this is the table 1.1. Substances, we have mercury 2 bromide, bromine, mercury. What they gave us? They gave us melting point, boiling point, density when liquid in gram per centimeter cube. A. Draw an arrow in figure 1.1 to show where the apparatus should be heated. The mercury 2 bromide should be in the molten state in order to conduct electricity. This is the setup for electrolysis. So you have to heat the mercury 2 bromide in order to convert this into molten state. So this will be the source of heat for this mercury 2 bromide. B. Name the item of apparatus labeled A in figure 1.1. Now this one is test tube. So you write test tube here. C. Name the process shown in figure 1.1 which breaks down mercury 2 bromide. See, the breakdown of molten mercury 2 bromide takes place in the presence of power supply. So this uses electricity. It's known as electrolysis. Electrolysis is the breakdown of ionic substance through the passage of current in the molten or aqueous state. D. The electrodes used in the process shown in figure 1.1 are made from platinum. Give 2 reasons why platinum is a suitable material for the electrodes. No, it must have free electrons, or you can say conduct electricity. It must not react or have inert behavior. And the melting point should be higher. They didn't mention the melting point of platinum, but they have mentioned the melting points of mercury 2 bromide, bromine, and mercury. So it should be higher than the melting and boiling point of both mercury 2 bromide as well as mercury. So you can write any two from these. Any two from, you can either write conducts electricity and one of these, high melting point. state the melting point. If you want, you can state the melting point of mercury or mercury 2 bromide. It's better if you want to show that you have to show the melting point of the one with the highest melting point. I mean, you can write inert or does not react. When you're saying does not react, so again, if you want to mention, you have to mention it does not react with either mercury 2 bromide or mercury or bromine. Or in case of mercury 2 bromide, you can even call it salt. Inert or does not react with either mercury 2 bromide mercury bromine. We get bromine during this electrolysis. Or you can, if you want, you can write the salt. No need to write the name of the salt. E. On figure 1.1, draw an X to show where mercury will collect. Mercury is a metal, it will gain electron and will be collected at the negative electrode. Should know which one is the negative electrode. So if you see a sign, this must be the cathode, which is the negative electrode. And this one is anode, which is positive electrode. So mercury should be collected on the cathode at cathode. Should be at this point. One. I've explained why ice is used in the experiment. If you look at the melting point of bromine, it's -7. And boiling point is 60, which means it's highly volatile bromine. So in order to collect this bromine, or you can say condensed bromine vapors, it will be collected, it will be produced as bromine vapors. Bromine vapors. Into next question, which is question number 2. A student investigates the rate of the reaction between aqueous iron 2 nitrate and aqueous sodium sulfate. The student does 5 experiments using the apparatus shown in figure 2.1. We are having a beaker, it's 100 centimeter cube beaker, aqueous sodium hydroxide is placed in it, and there's 50 centimeter cube of aqueous iron 3 nitrate. And there's a printed sheet, printed text below this beaker. Experiment 1. Use a 50 centimeter cube measuring cylinder to pour 50 centimeter cube of aqueous iron 3 nitrate into a 100 centimeter cube beaker. Stand the beaker on the text of the printed sheet as shown in figure 2.1. Use a 25 centimeter cube measuring cylinder to pour 15 centimeter cube of aqueous sodium thiosulfate into the beaker. At the same time, start a stopwatch. Stir the contents of the beaker. Look down from above the beaker. When the text on the printed sheet becomes visible, stop the stopwatch and record the time in seconds to the nearest whole number. Rinse the beaker with distilled water. Experiment 2. Repeat experiment 1 using 10 centimeter cube of aqueous sodium thiosulfate instead of 15 centimeter cube. Experiment 3. Repeat experiment 1 using 7 centimeter cube of aqueous sodium thiosulfate instead of 15 centimeter cube. Experiment 4. Repeat experiment 1 using 6 centimeter cube of aqueous sodium thiosulfate instead of 15 centimeter cube. Experiment 5, repeat experiment 1 using 5 centimeter cube of aqueous sodium thiosulfate instead of 15 centimeter cube. A. Use the information in the description of the experiments and the stopwatch diagrams to complete table 2.1. So we have experiment 1, 2, 3, 4, and 5. So volume of aqueous thiosulfate in centimeter cube. Now you see in each experiment it's changed. In one we are having 15, 2 we are having 10, then 7, 6, and 5. So I'm writing down the volume used here. 15 in this case, 10, 7, 6, last one, 5. Now stopwatch diagram, time taken for the text to become visible in seconds. For the first experiment, it's 24 seconds. If you look at this carefully, it's 24 seconds. We don't have any minute here. We have only 24 seconds. So I will write 24 as. For the second one, again, we don't have any minutes here. It's 0 minute, 0 minute, and 51 seconds. Here's the point, 51 seconds. Experiment 3. Now we have minutes here, and it has passed minute. We have 1 minute, 1 minute, and 1, 2, 3. The 3 seconds. So you have to add 60 plus 3. You know, 60 seconds are in 1 minute. So 60 plus 3 becomes 63 seconds. What about experiment 4? Again, we are having 1 minute in this case. And what about the second? We have 35, 6, 7, 8. 38 seconds. So you will add 60 plus 38. What you will get? You will get 98 seconds. Experiment 5. Again, we are having 1 minute. What about the seconds? We are having 55, 56, 57, 58. 58 seconds. So 60 plus 58, it becomes 118 seconds. B. Write a suitable scale on the y-axis and plot the results from experiment 1 to 5 on figure 2.2. Draw a smooth curve of best fit. So here's a graph. For your convenience, I've drawn the graph for you. This will be the plotted graph. This one for the 15 centimeter cube and this one for the 10 centimeter cube. Then we have 7 centimeter cube and we are having 6 centimeter cube. And the last one is for 5 centimeter cube at different time intervals. Moving to the next part, which is part 3. State why the contents of the beaker are stirred after adding the aqueous sodium thiosulfate to the aqueous iron 3 nitrate. Definitely, in order to mix the reactants, in order to mix the reactants. D. Deduce which experiment has the highest rate of reaction. If you look at this, this one is experiment 1. And it's taking only 24 seconds for the text to become visible. So definitely we have experiment 1, which has highest rate of reaction. So you write experiment 1. Part E, use your graph in figure 2.2 to predict the time taken for the text to become visible if the volume of aqueous sodium thiosulfate is 12.5 centimeter cube. Show your working on figure 2.2. So we have 12.5 centimeter cube is the volume. So 12.5 means this must be the volume of sodium thiosulfate, and you'll be getting the graph this point during the time also. So this will be the final graph obtained for this one. F1, explain why it would be an improvement to measure the volume of aqueous iron 3 nitrate in a burette rather than in a measuring cylinder. Definitely, burette have higher accuracy than measuring cylinder. So you write burette has high accuracy than measuring cylinder. Part 2, explain why it's not possible to use a volumetric pipette to measure the volumes of the aqueous sodium thiosulfate used in the experiment. Volumetric pipette is used if you want to have fixed volume, because here the volume is not fixed, it's not same in each run. So that's why we can't use volumetric pipette. So you write volume is not same in each run. You only can mention the volume of pipette, it's like 25 centimeter cube fixed. 3, describe how the reliability of the results of this investigation can be checked. Definitely, you can compare, repeat the experiment and compare the graph obtained, or you can even repeat it and exclude anomalies. Repeat and exclude anomalies. Right? Repeat and compare the graph obtained. D, describe how the results of the experiments would change if the experiments are repeated using a narrower and taller beaker. Definitely, it will increase our time, or more time will be taken because depth of liquid increases. You write change in result, more time will be taken. More time will be taken. And for the explanation, you write depth of liquid increases. Depth of liquid increases. The next part, which is part H, describe additional measurements that must be taken to determine whether the reaction in this investigation is exothermic or endothermic. Measure the temperature before and after the reaction. Next question, which is question number 3. A student tests two substances, solid M and solid N. Test on solid M. Table 3.1 shows the test and the student's observations for solid M. So here's table 3.1. He has performed test 1, which is a flame test on solid M, and lilac flame color is obtained. If you look at the list, in the flame color, we have sodium ion having, potassium ion, sorry, having lilac flame. So we have K plus ion, definitely. Test 2. Dissolve the rest of solid M in water to form solution M. Divide solution M into four portions. In the first portion, the student is adding dilute nitric acid followed by few drops of aqueous silver nitrate. We're getting cream precipitate. This is the test for the anion, especially for chloride, bromide, and iodide. And if you see this, cream precipitate is obtained for the bromide ion. So you must have Br minus here. Test 3 to the second portion of solution M. Add aqueous sodium hydroxide dropwise until in excess green precipitate forms. The precipitate remains when excess aqueous sodium hydroxide is added. So it is a test for the cations. It must be Fe2 plus because in this case it remains, it's not soluble. In case of chromium 3 plus, it will also form green precipitate but remain dissolved or soluble in excess of sodium hydroxide. So it must be Fe plus 2 or 2 plus. To the third portion of solution M, add 1 centimeter cube of aqueous sodium hydroxide and a small square of aluminum foil. Warm the mixture and test any gas produced with damp red litmus paper. Litmus paper remains red. Now this is a test for the anion, which is nitrate. Here's the nitrate. Here you perform the test for the presence of nitrate and the gas produced is ammonia. And if you test the ammonia gas, it has to turn blue, red litmus paper to blue. So it must not be having NO3 absent. You write NO3 minus absent. Test 5. With the fourth portion of solution M, add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. White precipitate forms. This one is for the negative ion sulfate. See sulfate, it forms white precipitate. So it must be having sulfate. A. Explain why a yellow safety Bunsen burner flame is not suitable for a flame test. Because this yellow flame masks the color caused by the metal ion. If you want, you can name the ions. Yellow flame mask the color caused by the metal ion. If you want, you can write the name of the ions like Li. It will give red. Li plus. Sodium Na plus gives yellow. Look at the list for your convenience. Ca plus 2. These colors are similar. Orange, red. You can't detect this easily if you are having a yellow flame. B. Identify the 4 ions in solid M. So we have identified K plus, Pr minus, Fe plus 2, and SO4 minus 2. So I'm going to write the formula for the name K plus. You can write potassium, Br minus, or bromide. Never write bromines, bromide. Fe plus 2 or iron 2. Last one, sulfate SO4 minus 2, which is sulfate. Test on solid N. Solid N is ammonium carbonate. Now they have gave us the name of the substance, which is ammonium carbonate. Now this makes your life easy. You can easily record down these spectral observations. Record the spectral observations. See, the student transfers approximately half of solid N to a boiling tube and adds about 10 centimeter cube of dilute sulfuric acid to the boiling tube. Any gas produced is tested. So, observation, it's effervescence, or you can write bubbling. It's due to the carbon dioxide produced. So, ammonium carbonate reacting with sulfuric acid, we get three products: salt plus water plus carbon dioxide. The bubbling is due to the production of this carbon dioxide gas. So you write bubbling or effervescence. Now they are saying any gas produced is tested. So look at the test for the carbon dioxide gas. Here's a carbon dioxide gas. It turns lime water milky. So you write turns lime water milky. The student dissolves the remaining solid N in water to form solution N. Solution N is divided into two portions. Part B. To the first portion of solution N, a student adds about 2 centimeter cube of aqueous sodium hydroxide and gently warms the mixture. Any gas produced is tested. So you see here its ammonium ion is there. NH4 ion is there. Ammonium ion. If you look at the test for the ammonium ion, here's ammonium ion. The test is with sodium hydroxide, it will produce ammonia gas. And ammonia gas is tested with litmus paper. It will turn to blue. So you write turns damp red litmus paper blue. Turns damp red litmus paper blue. Part E. To the second portion of solution N, the student adds excess aqueous ammonia. Definitely it won't have any effect, so you will write no change. So there's already ammonium ion. So ammonia does nothing with this ammonium ion. Okay, last question. Question number 4. Limes and lemons are citrus fruits which contain aqueous citric acid in their juice. Citric acid reacts with alkalis such as aqueous sodium hydroxide. Plan an investigation to find which of lime juice and lemon juice contains the most concentrated aqueous citric acid. Assume that citric acid is the only acid present in the juices. Your plan must include the method to use, how the results are used to determine which juice contains the most concentrated aqueous citric acid. You are provided with lime juice, lemon juice, aqueous sodium hydroxide, and common laboratory apparatus and chemicals. The total mark for this question is 6. You don't need to draw any apparatus. So they are asking for the explanation. And if you look at this, we have to go for titration because it's reacting with aqueous sodium hydroxide. And we are going to check the strength or concentration of lime juice and lemon juice to see which one is more concentrated. So we'll go for titration method. So you straight away write method is titration. So we get 1 mark for this. Next point will be specified volume of juice or aqueous sodium hydroxide. Now rest you can write any 5 from these, any 5 from. So in case of you are taking juice for titration, number 1, In case of volume of juice, means that you are going to titrate it with the aqueous sodium hydroxide. So these steps will be followed. Add acid alkali indicator to the juice. Add acid alkali indicator. Name the indicator you are using. Indicator to the juice. Name of indicator. Pour juice in a conical flask. For titration. Add sodium hydroxide from billet. Mix the contents. Juice change color. Now, juice that needs most sodium hydroxide is concentrated. Juice that needs most sodium hydroxide is concentrated. Now, this is the one way of doing this question. You can go for the other way, that is in case of you are taking sodium hydroxide in conical flask. So I'm going to write in case, I write or any five from these. Any five from this one. In case of volume of sodium hydroxide. We will add acid alkali indicator. The sodium hydroxide. Name of indicator. For sodium hydroxide in a conical flask for titration. You will add juice from burette. Add juice from burette to sodium hydroxide. Mix or swirl the content. Mix or swirl the content. In the flask. Sodium hydroxide change color. Here, sodium hydroxide change color. Less volume of juice used means it is most concentrated. Less volume of juice used means that it is most concentrated. So in this way, you're going to solve this question. I think the explanation is enough here. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.